Chebyshev inequality, okay? This is the last topic I covered last week. At the end of the last time, in the last couple minutes, I find I make a mistake, okay? This is what I wrote last time. And this is wrong, okay? Should be this one here. The equivalence is this. Either this one or this one, okay? Look at the sign, greater equal to, change it to less equal to. And less or equal to 1 minus k squared, this is greater equal to 1 minus k squared. Last time I put this one here, that's wrong, okay? I realized in what? Last minute of the class last week, okay? Please make an update here. About probability, okay, about probability. Flip a fair coin twice. Very simple example, okay? Flip a fair coin twice. What are the possible outcomes? Okay, what are the possible outcomes? And how likely? How likely do we see two heads in a row? Okay, let's begin with the RE. What is RE? RE is an abbreviation of random experiment. Random experiment is an experiment whose outcome we don't know before we actually perform it, okay? And the reason why it's random, because it has at least what? Two possible outcomes. So you need to do it to see which outcome what shows up. So to be qualified as a random experiment, we need to have at least two possible outcomes, okay? So look at this experiment here. Flip a fair coin twice. What are the possible outcomes, okay? The collection of possible outcomes is called sample space. Sample space is a collection of all possible outcomes. In our example here, possible outcome, head, two heads in a row, or head-tail, or tail-head, or what? Tail-tail, okay? Or tail-tail. Altogether, there are four possible outcomes you can expect to see. after you flip a fair coin 2 times. Okay, what are the possible outcome? 1, 2, 3, 4. Okay, the notation we used before is number of possible outcome in the sample space is 4. Okay, 4 elements in this set. Okay, we say 4 possible outcome. So sample space is 4. Possible outcome in the sample space is 4. Okay, some book you may find they use what? Omega. That's also another common notation to denote the sample space. Okay, and how likely do we see 2 heads in a row? Okay, so how likely we see 2 heads in a row? Head, head. Okay, head, head. How likely you see 2 heads in a row? Now, since this is a fair coin, okay, first one you see head, 50% chance. Second one still head, still 50% chance. So 50 times 50, that's what? That's a quarter, 25% chance. Okay, 25% chance. So this is a typical probability questions. Okay, and we can see in order to modify, make it become what? A model, we need to make a lot of assumptions. Okay, for example, here you may want to say, well, this is an equiprobable sample space because the coin is a fair coin. So chance of getting head is what? 1/2 times 1/2, 25% chance. Okay, now, and because the coin is a fair coin, this is the same probability to get what? Head tail. Same as tail head. And same as what? Tail tail. Okay? They're all equally likely. All equal to what? 25% chance. If in the sample space, all possible outcomes are equally likely, okay? The sample space is called equal probable sample space. All the outcome in the sample space all the possible outcomes in the sample space are equally likely to happen. Okay, that's called equiprobable sample space. Okay, equiprobable. When sample space is equiprobable, how we assign probability measure to individual events of subset of what? The sample space. For example, how likely you're going to see 2 heads in a row? That kind of probability. If we call this is event A, then for equal probability sample space, okay, how we set up their events? Events are the subset of the sample space, okay? Subsets of events are called subsets of sample space, okay, are called events. So how we define the probability measure of event? We define as number of outcome in A divided by number of outcome in the sample space. This works only when the sample space is what? Equiprobable. Okay. Now let's look at random variables and their distributions. Use the same example. We roll a fair coin twice, and we are interested in X. What's X? Number of heads resulting. Look at the sample space. We can see two heads in the row. And we can see head tail, and we can see tail head, and we can see what? Tail tail. In this case, the sample space can be written as what? When X is head head, you see two heads in the row. So we say X is what? 2, because you see two heads. And head tail, tail head. This is X equal to 1, because you only see one head. And then tail tail, X is 0. Okay? Why we create random variable? As you can see, this is for notational convenience. Can you imagine if we flip the coin 10 times? Okay? Say we flip the coin 10 times. If we flip the coin 10 times, the sample space, the first one, will be head, 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 head. But if you use random variable, all you need to do is say X equal to 10. Okay? Not to mention next one. Exactly 9 heads. And the last one is what? A tail. Okay? How many different outcomes? You have 10 of them. Can you imagine? Well, you can write like this. Why bother to write like this? This is like what? This is like a torture. Too complicated. Okay? So why we invent random variable, as you can see, for notational convenience. Okay? This will be way easier. Okay? So this is a random variable. Okay, random variable. And the reason we invent random variable is for notational convenience. Okay. Now next, let's look at the probability distribution of X. When we say distribution of a variable, what does that mean? That means two information need to be included. First one, you need to tell me what are the possible values of X. And next one, you need to tell me how often or how likely do we see them. Okay, in our case, X has only 3 possible values. x equal to 0. In two flips, you see two tails in a row. Exactly one head or exactly two heads, okay? Exactly one head, exactly what? Two tail. As I mentioned, this is 1/4. And x equal to 1, that probability. Add up to 50% chance. And x equal to 2. Two heads in a row. That is what? 25% chance. Okay? So, if you add the number up, they add up to what? They add up to 100%. Okay? On the top of the table, this tells us what are the possible values. The bottom tells us how likely we see those possible values. So this is a probability distribution of a random variable. Next, introduce you expected value of x and variance of x, okay? What is expected value of x? If you really flip the coin 3 times, make a guess. What number you're gonna guess? You're gonna guess what? Expected value of x, okay? It's a 1-1 average from your experiment. Every time you flip 3 coins, or flip the coin 3 times, and record how many heads you get. Say you repeat this process for 1,000 times. And every time you find a number, you add it up. Then after 1,000 experiment, you add all the heads resulting from each experiment, divided by the number of experiments. You're going to get this number, expected value of x, okay? Around this number. That's what you expect to see on x, okay? What you expect to see on x. So in our example, how we find this value, okay? The notation used in the book is what? Is mu x, okay? And this is the variance of x. So, question. If we flip the coin, three times, what is the number? What is the number of heads? You expect to see? Okay? If we flip the coin 3 times, what is the number of heads you expect to see? That is what we call expected value of x, okay? I ask you to make a guess. And you're going to guess as EX, okay? How you find this number? Well, summing all possible value of x times what? The probability of x, okay? To make this calculation, we need to check out our probability distribution table, x and px. When x is 0, that chance is what? 1 over 4. When x is 1, that chance is 2 over 4. When x is what? 2, that chance is 1 over 4 again. So this formula says you can see what? 0 heads, that means 2 tails in a row. That chance is x equal to 0. Plus, you see 1 head, exactly 1 head. Weighted by its what? Chance, x equal to 1. Plus, you see 2 heads, weighted by its chance, x equal to 2. We know x equal to 0, that chance is 25%. Plus 1 times x equal to 1, this is 50% chance. Plus 2 times this one is 1 over 4. Okay? So this is 2 over 4 plus what? Plus 2 over 4. Did I? Let's see. What do you get? You get 1 head. When you flip a fair coin, okay? How many heads do you expect to see? If you flip a fair coin 2 times, how many heads do you expect to see? You expect to see 1 head. That makes sense, right? That means every 2 flip, you expect to see 1 head, okay? That makes sense because this is a fair coin. Can I move on? Let's go. Now, if we flip the coin, listen, this is a mistake. Originally I write 3, I changed to 2, okay? This is our experiment. If we flip the coin 2 times, what is the number of heads you expect to see? Make a guess. You're going to guess 1, okay? You're going to guess 1. And second question, how good is your guess? How accurate is your guess? This is described by what? By standard deviation, okay? And standard deviation square is what we call variance of x. Standard deviation square is what we call variance. And how can we find variance? This is the definition of variance, okay? Variance of x is defined to be expected value of x minus ex, the whole thing squared. Expected distance square to the center of x distribution, measured by what? Mean of x, okay? Expected distance square to the center, that is called variance of x. And there's a computational formula. It's called shortcut formula. This can be proved, they are equal, okay? But I'm not going to prove in this class. As long as you know how to use it, I'm happy, okay? Now, variance of x is expected value of x minus ex squared. Apply to our example, how the computational formula works. The variance of x is expected value of x minus ex squared. Now, in our example, EX is 1. Okay, so this is expected value of x minus 1 squared. So summing all possible value of x minus 1 squared times px. Okay, now, when x is 0, remember you can get 2 tails in a row. That means what? No heads. 0 minus 1 squared times how likely x equal to 0 plus when x is 1 times probability x equal to 1 plus x equal to 2 times probability x equal to 2. So this is 0 minus 1 squared is 1 times x equal to 0 is 25% chance. 1 minus 1 is what? 0, 0 squared is 0, okay? Times this is 2 over 4. Plus 2 minus 1 is 1, 1 squared is what? It's still 1. And x equal to 2 is 1 over 4. So when you add it up, they add up to what? 2 over 4 is 0.5. Okay? Okay, let me try one more time. I'm recording now. So use this one as an example. I introduce you what is EX. The weighted average, weighted by probability. The weighted average of all possible value of x. And that is what you expect to see on x. In our example, when you flip a fair coin 2 times, you expect to see what? 1 head, okay? And how good is your guess can be described by variance of x or standard deviation of x, okay? Follow this formula. We find the variance of x is actually 0.5, okay? It's actually 0.5. And that means standard deviation is 0.707, roughly, not exactly, okay? Standard deviation square is what? 0.5, okay?